coming up, here's what you definitely need to know from your previous chemistry courses to be successful. So I usually spend 2 or 3 days going over this as a Chem 30 teacher before I get into the Chemistry 30 material. So the very first part is hopefully you're looking at this and thinking you definitely know it, and that's naming compounds. So naming ionic, which would include bases, naming molecular and covalent, and naming acids. So I put here you have to just identify it, because as long as you can identify an acid, you can use the data booklet. So just a little bit further, ionic, you know it's ionic because you will see a metal present, or anything that's polyatomic. So just a reminder that polyatomic ions are what's in the box on your periodic table, like above the periodic table. So if you see a metal or the polyatomic ion, you are going to be ionic. Now, I also wrote here includes bases. One of the polyatomic ions is the hydroxide ion, right? So that has a negative charge. If you see this, so the whole thing's negative. If you do see this and you're ending in OH, you know you're going to be a base. So for example, like NaOH, we know it's ionic because you see a metal. We know it also is included as a base because you see OH. Now with molecular, you know it's molecular because you only see nonmetals present. And then the last one, acids. There's 2 types of acids you have to identify. One that would start with H, and the other is when you end in COOH. As long as you identify that you have an acid, then go to the data booklet, look up your acids page, and find it. So I know if you have previous courses, there are rules to naming acids, but there's so much you have to remember in Chem 30. Let your data booklet help you here. So the next part you should be really good at is identifying types of reactions and predicting. So if you're given 2 reactants, knowing what your products are going to be. So for instance, if you have composition, also known as formation, you have 2 elements coming together to form a compound. So if you were given those 2 elements, you should be able to predict that compound. Decomp is the opposite of formation. You start with a compound and it will break up into 2 elements. Single replacement, you're going to start with a metal or a non-metal, or a gas, so like sodium, and then you're going to add it to a compound. So an example here could be strontium hydroxide, which again ends in OH, you know it's a base. So if you had something like this, you know it's single replacement because you have an element by itself added to a compound. So in this case, we would take a look and see our metal swapping places, and then go ahead and predict your products. Double replacement is a little bit different because instead of just having an element by itself, you're going to have 2 compounds. So for instance, I could write NaCl, react it with the same compound as the single replacement, but now it's double because you have 2 compounds. And in double replacement, your metals will swap places, and then you can predict your new compounds. Remembering that a special type of double replacement reaction is neutralization, and that is when you start with an acid, you add in a base, and you always get a salt and water as your product. Combustion reactions, you know you have a hydrocarbon to start with, so that just means a certain amount of carbons are attached to a certain amount of hydrogens, and you always add in oxygen, and your products will be carbon dioxide and water. So this part, I think the hardest part when it comes to combustion is 1, recognizing it, and then the second part is balancing it. So for all of our reactions, not only identifying, predicting products, but once you're done, you should be very good at balancing. If any of this you're wondering or kind of questioning, leave me a comment and I could do a more detailed video on all of that. Now moving on to something else that is a huge part of Chemistry 30 is net ionic equations. So when you're using a net or writing out a net ionic, you're showing exactly what's reacting and taking out all those spectators. So here's an example. You always start with your balanced equation, and then you break up what you can. So in this equation, we can break up ionic compounds in solution. You can also break apart strong acids. So there's a whole list that you can break apart. So you just want to know what you can break apart. But what's most common will be your strong acids and ionic compounds in solution. So now that I have that, I would go ahead and write down what I have, but start to break out apart into ions. So when I have copper nitrate, to form this compound, I would have had copper 2 ions. I know that because of my swapping and dropping and my 2 being a subscript. So now I have that. I also have 2NO3 negative to write down. And I know that there's 2 because again, that's subscript there. Now the other part, just to mention here, is don't forget the charges. So when you're writing out ions, make sure you have like copper 2 positive, nitrate negative. If you're missing that, there's often mistakes that come with that. Now on the product side, this 2 out front means I have 2 of the elements and polyatomic ions within. So I would have 2 silver ions. I'd also have 2 nitrate ions. And then that copper solid, can't do anything with it, so I just write down the same thing again. So now that I have all of that, now I go ahead and cancel out my spectators, and your spectator has to be exactly the same on both sides. So here, 2 nitrate ions are canceled. And then just one more thing to point out here that's a common mistake is like this one here, just because you have 2 silver as a solid, that's not the same thing as 2 silver ions. So because this does not look exactly the same, it cannot be canceled. So when I'm done, I would just go ahead and write down everything that I was left with that did not cancel out. And these reactions can get a lot longer and a lot more complicated, but the steps are the same. Now, moving on to the next part is calculating molar concentration. Now with this, I just started kind of with half of what you have to do because the last step is pretty easy. So molar concentration means you have the units moles per liter. So an amount of moles divided by liters. So with this one, when you're asked the amount of calcium chloride based on the grams involved, if I want a concentration, it would just have to give me a volume to divide by when I'm done. So just make sure that you know how to get to moles given grams, and that means you need molar mass. So you get the molar mass of calcium chloride, which is 110.98 grams. So that's something, grams per mole. So that's something you want to be comfortable calculating. And then you start with what's given, 25.9 grams, and you multiply it by that ratio. So this is 110.98 grams per 1 mole. I need to arrange my fraction or my ratio in a way to get grams to cancel. The only way to do that is to flip the ratio, because now I have grams in the numerator, grams in the denominator, and that can cancel. When I'm done, I have my amount in moles, and that's what I need to get to. And then once I have that, if I was asked a concentration question, I would just take my amount of moles and divide it by those liters. The other part that we need to be good at is some stoichiometry. So in this question, we have our balanced chemical equation. We are asked for a certain amount of sodium hydroxide being reacted with the aluminum sulfate, and tells us when this happens, 0.0400 moles of aluminum hydroxide is precipitated. Then it's asking the concentration of NaOH. So in this any straight question, your first step is to get to moles. So like what we did in the previous example, get to moles. If we are already given moles, that's going to save you a step. So we have 0.0400 moles of sodium hydroxide. We are going to multiply this by the mole ratio. So first step, get to moles. Second step, use your mole ratio. So I am now at, there should be an arrow here. I am now at moles of aluminum hydroxide. I want to use my mole ratio to turn it into moles of sodium hydroxide. I'm sorry, I'm going to, yeah, that is what I want to do. So this one, I just wrote down wrong. This was my aluminum hydroxide. All right, what was given here? Sorry about that. So AlOH3. So now that I have that, I want to go ahead and multiply. So I want to put the 2 moles of my known in the denominator and my unknown in the numerator. So hopefully you can see why, based on our ratios, and that, I don't know why it went away. Because now, based on this, your moles can cancel, and you're now at moles of sodium hydroxide. And then to get to concentration, we need to divide by our volume, but your volume must be in liters. So turn that to liters by dividing by 1,000. And then to just continue the calculation, we can put 1 in the numerator and put 0.15 liters in the denominator. This is just a step showing that you can divide by liters. Go ahead and put that all into your calculator. And why doesn't my pen want to work? Come on. Did it die? Hopefully not. Oh, that's fun. Okay, so I hope you're still with me. I'm sorry about that. So then the last part, I put it into my calculator, and when I do, I would see I get 0.800 moles per liter. And then that reminder that the other way you can see this unit is using a capital M for molarity, and that means the same thing. So 2 ways to show that unit. Now, the very last thing that we would take a look at here is titrations. So titrations, you also definitely want to understand. In Chemistry 20, you focus on acid-base titrations. In Chem 30, it's the same type of concept, but it's not just acids and bases. We do different type of titrations as well, mainly redox. So when you're doing a titration, because it is essentially stoic, you do want a balanced chemical equation. So in this one, you have NaOH reacting with hydrochloric acid. So I could put my states here as well. And your products are always going to be a salt, so NaCl, and water. In this equation, you don't need to add any coefficients to balance because this reaction is already balanced. Now, with your titration, you want to remember that you need to calculate your average volume if you're given more than one trial. So I would just take the difference here from my final minus my initial to see my total volume that I'm getting. And then I also want to remember that you have to keep values within 0.2 of each other. So these ones all work, so I can add them all together and divide by 3. So your average volume, once you add and divide by 3, is 31.75, and this is in milliliters. So now that I have that, then I can go ahead and start the stoic. So I start with what I know, and that is my volume, but I need my volume to be in liters. So I'll take that and divide it by 1,000. So I have 0.03175 liters. And now what I can do is get 2 moles by multiplying it by the concentration of HCl. So I know that went away, but I can keep going here. So multiplying by the concentration, 0.125 moles of HCl over 1 liter. Now I have, with that, I am now at moles of HCl, and everything was 1:1. So I can use my mole ratio, so 1 mole of NaOH divided by 1 mole of HCl. So that gets my moles of HCl to cancel. That was my mole ratio. And the last thing is to divide by my volume, which was my sample of NaOH. Again, that needs to be in liters, so 1 over 0.01. So sorry, I know that's getting messy, but now once I have that all, just doing my solution stoic, put that all in a calculator, and once you round, you'll get 0.40 moles per liter, or you can use a capital M to show your concentration. So just to go over that one more time, get your average volume, use your volume and the concentration of what you know to get to moles, then use your mole ratio to turn your known into your unknown, and then divide by your final volume to get that concentration. So I hope you found this helpful. That's a brief overview of what you should know. I do have a review activity you can try on my website, going over it in a little bit more detail, and I'll put a video up shortly with the answers to that. So I do hope you will try it, and if you are in Chemistry 30, please follow along on my website. I have everything you need there. It's just a very quick way to show every single topic and how it's all arranged. So as always, thank you for watching, and I hope you find this helpful.